So as of recording this anyway, this is new territory I haven't addressed with various classes. So you can look ahead if you like. And the topic is solving each equation, and it involves radicals. And that means with solving, it's all about undoing. It can be grouping things and using other kind of strategies. But the biggest thing is you're trying to get to x, isolate an x all by itself. In the approach to this, the things you want to think about is I want to isolate the radical. That's first. Isolate the radical. If you can get it alone, then the next step is real slick. You want to square both sides after you, but you can't do you can do it before, but I think it makes your mathematics a little bit more tricky. So we'll just hang in there. If you can see about isolating the radical, this is isolated. This is what I mean by isolation. A nicely isolated radical means it's a radical expression, nothing else added or subtracted to it at that point. So here's how the squaring goes. Throw some parentheses in there, square both sides. We're doing it to both sides, maintaining balance. We are going to enter in to the ultimate pre-calculus sin, and that is do not distribute the power. So do not distribute power over a plus or a minus, is over a sum. And that is rule number one. It's the biggest mistake that I encounter, probably number one in all math classes I teach. What that means is x minus 5 squared that you see right here is not x squared minus 5 squared. No. It is x minus 5 times x minus 5. You have to factor that. You have to distribute that out. That expression becomes a trinomial when we're all done with it. Squaring on the right-hand side, that's the fun part. The whole reason we did this is because we square both sides to get rid of that radical. Squaring a square root cancels it, and we get x plus 1. And then ultimately we can go about the next phase, which after that, step 4 is you can solve this or use the quadratic equation. So depending on what type of equation is, solve however you can, and if it's quadratic, then you have two options that we've been learning up above. Then you want to factor or use the quadratic formula. And quadratic formula is pretty robust, so you can use that anytime. It's kind of your go-to no matter what. It's just a handy-dandy little formula. Sorry for the bad handwriting. So that's what I'm going to do on this one. I'm going to FOIL this out. Distribute x times x squared, x times negative 5 minus 5x, negative 5x, and then finally 25 plus 25 equals x plus 1. That's the result of that. Those two middle terms are like terms. They combine. And there's a way to do that quickly and mentally. It'd be good to catch on to that as the term goes on. But this is the result of squaring both sides. Okay, that's where we're at. Now, if we're solving this, you know it's a quadratic if the degree of this is 2. And when I say degree, I mean the highest power that you see in this expression is 2. Thing's a quadratic. If we graphed it, it'll be a parabola. The thing you want to set it equal to 0. We said, I think up here, solve. If it's a quadratic, I think I forgot to mention set equal to 0. And then you can factor or use the quadratic formula. But those are the big steps that go with that, so keep that in mind. We have a quadratic. We are going to set it equal to 0. And that means subtracting x and subtracting 1 from both sides. And looking at what we get. X squared minus 11x. And this 2 minus 1 that you see right here makes negative 1. And we're equal to 0 now. So if you want to factor this, if you think you can find two factors of negative 1 that add to negative 11, good luck. They don't. So we have to use quadratic formula. And we get x is the opposite of 11, negative 11, sorry, plus or minus square root b squared, 11 squared minus 4 times 1 times negative 1, all over 2 times 1. That's me working quickly through the quadratic formula now. It needs to be pretty slick in your repertoire. We have 121 plus 4, which is 125, all over 2. And interestingly enough, the square root of 125 is not a nice, it's not a perfect square. It's not a simple number. There's ways to make it into something nicer. And we'll talk about simplifying radicals, I think, a little bit later. But ultimately, we just have two solutions. I'm going to leave it relatively simple at this point because we have other fish we're trying to fry. but I see x is 11 plus the square root of 125 over 2, and I also see that x is 11 minus the square root of 125 all over 2. Those are two solutions. Now, if I go to another expression right next to it, this is also with radicals, I don't have an isolated radical this time. So one step to isolating that radical, because I wrote some steps over there, isolate the radical. To get that to happen, check mark, I have to actually subtract 4 from both sides. You don't want anything with this. You want this alone, very, very, very alone. So subtract 4 from both sides, subtract 4. And what we end up with, negative 3m plus 10 under the radical is equal to m minus 4. That's when you can square both sides. So check, we're going to do that. We're going to go in and square both sides. And then we are left with negative 3m plus 10 on the left. That's why we squared both sides. And on the right, not m squared minus 4 squared. No, 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 no. It is m minus 4 times m minus 4. Get used to writing that. And we're going to do a little work. This will be quadratic when it's all done. We'll get it equal to 0. We'll do something fun. Distribute, so it's going to be m squared minus 8m plus 16 when it's all said and done. You're welcome to do it the long way. If I want to get it equal to 0, that means this stuff on the left needs to move to the right. So I will add 3m to both sides. And I will subtract 10 from both sides. And that will give me 0 on the left. And then the m squared is going to be followed by negative 5. I wrote an x in there. I do that a lot. Change the variable. And then negative 16 minus 10 would be just 6. So we're adding 6. Now, do we have factors that add to this? We might. Negative 2, negative 3. Oh, yay. So what's cool about the fact that we can factor this, you can use quadratic formula for solving for m in this case. Or this is the one where it gets important to factor. You can write this in factored form and get solutions, the zeros, pretty quickly. We know that negative 2 and negative 3 add to negative 5. They're factors of negative 6. So we're going to do m minus 2 and m minus 3. That allows us to say, hey, if I want to just get an output of 0, all I have to have is what number makes this 0, or what number makes this 0, because then 0 times any number is going to give me 0 as my output. So we look for what's called the zeros, real quick numbers that we can plug in to give me an output of 0. And it's usually pretty quick on these. Hey, 2 on the left. M equals 2. That'll work. M equals 3. That's a 0. Those are numbers I can substitute in to satisfy this equation. So from the beginning, these are the two solutions. Now, solutions that don't work is my last piece of work. There is this idea that they're radicals, not all solutions that you get are worthwhile or would work. So, and I'm looking through this. This is what you're protecting against. Your radical cannot take the square root of negative numbers if we're going to stay in the real number. So what we're looking for extraneous solutions which are non-real solutions when it deals with radicals. So it's not that they're bad, it's just that they're imaginary. If I put 2 into the original equation, in for m, 3 times 2, negative 3 times 2 is negative 6 plus 10, no problem. Get the square root of, I don't know, 4 or something. That's 2, no big deal. We're good to go. But we want to look at the next one. What about 3? If I put 3 in there, what's going to happen there? 3 times 3, that'd be negative 9 plus 10. Oh, nicely. It all works out. Nothing to worry about. Okay, so those two solutions both work in that situation. On the other one, now I didn't simplify these very well, but I know the square root of 25 is kind of a little bit more than 11. So I know with my solutions that I do have, this is a nice positive x. If I plug it in for x up above here in my radical up there, I'm going to add 1 to it, square root of a very nice positive number. However, this second solution, the 11 minus the square root of 125, is 11 minus something bigger than 11, so it'll be negative, and that's important. But it's not crazy negative, it's negative, it depends on how negative it is. If I substitute that back into my radical expression, will it cause me to give a square root of a negative number? that's the part we'd have to figure out to decide if that's extraneous or not. So I'll save that for tomorrow because we are working ahead. I'm kind of curious, would that one still work? Is that okay? Is that extraneous? And that sounds like a good thing to do tomorrow.